All right, in this video we're going to look at the product rule for derivatives, and we'll go through a couple examples. So here we have a derivative of product, and we're going to make the assumption that both f and g are differentiable at a point x, and so it's not going to be quite as nice as the add or sum, where we just take the derivative of the parts separately. So it's not the product of derivatives. It's the derivative of the first times the second function plus the derivative of the second function times that first function. There's another video, I think, where I go through the derivation. You also have it in your textbook where they use the limit definition of derivative. Another way we can look at it is if we call f, we call it a function, f of x is a and g of x is b. It is the derivative of a times b plus the derivative of b times a, or some folks like to call this as ABA. Now when we get into the quotient rule, we're going to have a variation of ABA, but we have another saying for it too. So we'll look at that in another video here. Anyways, let's go ahead and use this on a couple examples here. I think we got about 6 of them. So problem number 1, well, we're going to be finding the derivative. Okay, so we're going to start off with something pretty basic, and we're going to do the product rule on this, and now this one we could have FOILed it out and just used the power rule, but here we're going to identify what our first function is, which is 2x plus 5. Derivative of that is 2. Second function is 3x squared minus 6, and then the derivative of that is 6x. So f prime of x is going to be the derivative of the first, which is 2, times the second function, 3x squared minus 6, plus the derivative of the first function times the second function. Go ahead and distribute the 2 through, distribute the 6x through, and collect your like terms. And we have 18x squared plus 30x minus 12 is as the derivative there. Okay, let's try another one. Let's do f of x is equal to the square root of x times x minus sine of x. Okay, and then we'll go ahead and write ABA off to the side here. So the derivative of a times b is a prime b plus b prime a. A is going to be the square root of x, but it's easier to work with as x to the 1/2 power. A prime will be 1/2 x to the minus 1/2. B will be x minus sine x. Derivative of that will be 1 minus cosine of x. So when we take the derivative, it is going to be a prime b plus b prime a. Okay. So if you can get that far, that's great. Now what we're going to do is a little bit of fancy factoring. So you would have done this in pre-cal. I think I have another video where I go in a little bit in depth with this. So we want to get rid of the 1/2. Okay. So if I factor out the 1/2, it's like I'm dividing by it. You know, if I have 2x plus 6 and I factor out a 2, well, it's like I divided the 2x by 2 and the 6 by 2. Okay. So if I take this factor here and divide by 1/2, really what that's doing is if we divide by a fraction, we're going to flip it over and change it into multiplication. So really when I factor out a 1/2, I'm going to be multiplying by 2. Okay. Now the other thing that's going to be going on here is going to be a little tricky too, is the factoring out of the exponents. Okay. So let's just make something up. Like we got 2x squared plus x cubed, and you factor out an x squared. Well, when you factor it out, again, it's like dividing, so you have x to the 2 minus 2 plus x to the 3 minus 2. Okay, subtract your exponents. You'll have x to the 0, which just turns into a 1, times 2, which is 1. and then x to the first, like you would normally factor this. Okay. Now what we're going to do is we're going to factor out a minus 1/2. So when we factor out a minus 1/2, that is minus a minus 1/2. And when we subtract a negative, that's a good thing. So then that'll change that into a plus. Okay. So it'll be a little tricky there, but that's what we're going to do. And we want to be able to factor stuff like this because we may be asked to do other things. Maybe we're asked to take a second derivative, or we're looking for, extrema or something like that. So we're going to want to simplify it down because in its present form it is the derivative, but maybe we want to do something else with it. Alright, so we're going to go ahead and factor out that 1/2. So there it is. And then we're going to factor out the lowest exponent, which is x to the minus 1/2. So when we do that on that first term, that just removes this. So that's been factored out. Okay. Now that whole discussion about factoring out a 1/2 is really multiplying by 2. So then we got 2, 1 minus cosine x. And then a whole discussion about factoring out an x to the minus 1/2. Well, you're really just subtracting the exponents there. So that becomes x to the 1/2 plus 1/2, which is x to the whole. Okay, so just leave that stuff out in the front, and then we'll go ahead and we'll combine like terms here. So we got x, and then we got 2 times x. So that makes it 3x. And then minus sine x, and then minus 2x cosine x. Okay. And that's about as far as we can go with this. Maybe we talk about differentiability or looking for roots or something like that. This one's pretty awful looking derivative here, so we're more just focused on doing some of the mechanics here. So let's go on and let's take a look at another example here. And let's say we have f of x is equal to x squared times the cube root of x plus the cosine of x. And again, we're going to just write ABBA off to the side here just as a reminder. This one's going to be kind of a complicated one too, but it does give us some practice with some of our exponent rules and that kind of stuff. So our a is x squared, so that's not too bad. Derivative a is 2x, and then the b, we'll rewrite that as x to the 1/3 plus the cosine of x. So then for the b prime, bring down the exponent, subtract 1 from the exponent, derivative cosine is sine. Okay, so for our derivative, it's a prime times b plus b prime times a. All right. And what we're going to do is we're going to do some factoring again here. We do have a greatest common factor of x. We're going to factor an x out, okay? And then we're going to be a little bit tricky here, okay? So we have, we've got a 1/3, and I don't really want the fraction. I want to bring it out in front. So I'm going to do that. What that does is that divides this by 1/3 and this by 1/3. So what we're going to end up having is this is going to be a 3 sine. This is going to turn into a 6. So remember, when we're dividing, or when we're factoring out, we're really dividing. But if we're dividing by a fraction, then that's going to take the reciprocal. So I guess you can also say that this divided by 1/3, the 1/3 is what will absorb there. Okay. All right. So let's go ahead and do that. So f prime of x, we're going to pull out that 1/3. Okay. So then we're dividing by 1/3, dividing 1 by 1/3, and dividing by 1/3. Now, one thing, I'm dividing this, which will take care of all of this, and I wanted to focus on this canceling, but I also have to divide that when I'm dividing by that 1/3. All right. So then we'll also factor out an x, and then we got 6. Because the 2 divided by 1/3 is 6. 6x to the 1/3 plus cosine x plus x. I just brought that extra x out in front here. We removed one of them, but we'll put the other one out in front. And we got x to the minus 2/3 minus 3 sine of x. And again, that came from the dividing by 1/3 there. Okay. And we can distribute and kind of see what we got going on here. So we got 1/3 x, and then 6x to the 1/3 plus the cosine of x, 6 cosines of x, excuse me, plus x to the 1/3, because this is the same thing as 3/3, and then if we add those, that's going to give us 1/3. Where did the 3/3 come from? That's 1. Okay, minus 3x sine of x. We got like terms of the x to the 1/3, so we have 7x to the 1/3 plus 6 cosines of x minus 3x sine of x. Okay, so again, it's probably going to be a little bit harder than some of the stuff you'll see in your book, but it's really good practice of doing this factoring out the negative exponents and your trig rules, and getting good practice with that product rule. Okay. This one, let's see what we got going on. I think this one's sine squared. Is that what that? Okay, this is sine squared, and then we'll go ahead and write ABA off to the side again. Okay. So we don't have this one. We could also do with something called the chain rule, but we don't have that one yet. So we're going to write it as the sine times the sine. Okay. So A will be sine, A prime will be cosine. B will also be sine, B prime will be cosine. Okay, so we'll write it out as A prime B plus B prime A. So like terms, so we have 2 cosine x sine x as our derivative. Okay, so later on in the next section, we'll actually do the chain rule, which will give us another way of getting that derivative. Okay. All right, number 5, f of x is equal to the cosine of x over x to the 6th, and we'll just write ABA off to the side again, just to remind ourselves. Okay. So I'll have to rewrite this as cosine x times x to the minus 6. So A is cosine of x, A prime is minus sine x, B is x to the negative 6, and then bring down that exponent, subtract 1 from your exponent for B prime. So f prime of x is going to be A prime B plus B prime A. Okay, and then we're going to get into the factoring. So we're going to factor out the lowest exponents out of the x, which happens to be a negative 7. So we're going to be doing negative 6 minus negative 7. So that's going to give us an x to the first power. Here we would have negative 7. So that exponent would be 0, and you'd be left with just 1 there, times negative 6 and the times cosine. Okay, so factor out that x to the minus 7. We'll also factor out a negative. So you got sine x times x. We'll put the x out in front, and then plus cosine of x, and then times 6. And that's about as much as we can do there. Okay. This last example is going to take the derivative rule, and it's going to push it. Okay. So we'll pause it here, and let's say we're going to do it for 3 functions, a, b, and c. So what we can do is we can treat this as one function, the bc. So it'll be a prime times bc plus the derivative of bc times a. Okay. All right. So that gives us a prime bc plus, and then when I take the derivative here, then I got to do the derivative of bc. So the derivative of bc, well, that's just going to be ABA, but with different letters. So b prime c plus c prime b. Okay, so product rule b prime c plus c prime b times a. And I'm going to rearrange the order, but I have a prime bc plus a b prime c plus a b c prime. So I'm just rearranging the order. So you notice with each term, I took the derivative of one of the piece. So we took the derivative a, then we took the derivative b, then we took the derivative c. So this is kind of like the product rule for 3 functions. This last example, I'm going to take the I'm going to do the product of I think like 5 or 6 functions. So it's going to use the same idea. It's just going to push it a little bit further. So I think we're going to do something like sine cubed over x squared. And that can be done a little bit easier with maybe a combination of the product and the chain rules. But we can do it with the product rule here. Okay, so f of x is equal to the sine cubed x over x squared. Okay, and what I'm going to do is I'm going to write it out as the product of 5 functions. Okay, and like what we did with the ABC, taking the derivative of those 3 things, we just took the derivative of the first, left the second 2 alone, took the derivative of the middle one, left the outsides the same, and then took the derivative of the last thing, the C, and left the A and the B alone. So we're going to do the same thing here. So we're going to take the derivative of the first thing, so the derivative of the very first thing is cosine. Everybody else is the same, so I'm going to write it as sine squared x and then x to the minus 2 to shorten it up. Then we'll take the derivative of the second function. The derivative of sine is cosine, and we can shuffle the order around, cosine and then times sine squared and then x to the minus 2, and then do that for the third sine there, so same thing. Okay, and then we'll take the derivative of those x's, so the derivative of that x to the minus 1 will be negative x to the minus 2. There's 3 sines and an x to the minus 1 left over, and then we'll do the same thing for the last term there. So then we'll collect our like terms. We have 3 of these cosine x sine squared and then x to the minus 2, and we have minus 2 of these sine cubes x to the minus 3. Okay, so we're going to factor out, looks like we can do a sine squared, and then we can also do a negative 3 here, x to the minus 3, so we'll be subtracting a negative 3 from both of these exponents. So this exponent will become a 1 and this exponent will become a 0. Alright, so factor out the x to the minus 3 and a sine squared, and what we got left going on is a 3x cosine x minus 2 sine x. Okay, and I guess I could ask possibly something like that as a bonus problem on a test or something like that. I like to do that with the chain rule too. You can have some pretty cool nested sets of functions. Okay, I'll make another video on the quotient rule. I do have a number of other videos on product and chain rule and the quotient rule out there, so you're welcome to check those out if you want some more examples.